Good morning to all. Today we are going to study about procedures. In the previous session we have discussed about interrupts, what are the types of interrupts, what is an interrupt cycle and its programming. Today we are going for procedures. So what do you mean by procedure? So as in our C language we have functions. So what the purpose of functions is, whenever we are calling a function, it goes that function, executes that function and again return back with the help of ret. So in the same fashion, in assembly language programming, we have procedures and macros. Other than interrupts, we have procedures and macros which will stop the current execution and go to that corresponding calling, whether it is a procedure or whether it is a macro. It executes that procedure and with the return again return backs to the normal program, original program. So first of all, what is a procedure? Is nothing but it is a set of instructions which we are executing for a specific function, specific procedure, specific macro. So writing and using procedures, what it does is, when we are using a procedures, it avoids writing the same sequence of instruction again and again. It will be written into a separate subprogram and call that subprogram whenever necessary. So we have a group of instructions which are written for specific purpose. So whenever we require the specific purpose to be performed, we have to call by using call instruction. By using call instruction, call whatever the procedure name or whatever the procedure variable name you have given in the program. So we have two instructions for call and ret. Call for calling the procedure and ret is for returning back into the original program. So it stores the address of the next instruction to be executed after the call instruction is to stack. So after call instruction, it moves the address of the call, and this address is called as the return address. And return at the end, this is nothing but at the end of the procedure we will be writing this ret instruction. It copies this value from stack back to the instruction pointer, nothing but back to the normal or original program. So this is how the chart will be, the flow chart will be. You can see here main line or calling program, nothing but we are writing the program and in between we got some call of our some procedure. So it stops here, go to that procedure instructions. So the address of the procedure instruction will be stored into the stack and that will be executed, and when return instruction comes into the procedure, the stack will come the instruction pointer address, so that the next main line instructions will be get executed. So this is how your single procedure program works. If you have multiple number of calls inside your calls, so in the same fashion it will stop for the after getting the call instruction to the procedure, and in the procedure while it executing, if we give a call to other procedure, then it goes to that and completes the first lower level procedure, then again comes back, then completes the procedure and again coming back to the main line or original program, main line instruction. This is how the chart of for call and ret instruction. When we are calling, it is calling or it is going to the function in C, and in assembly language it is procedure. Returning it should be must in any procedure, so which tells the assembler that the next instruction to be executed is pointing with the help of IP. Now first, creating procedures. How will you create a procedures? Large problems can be divided into smaller tasks to make them more manageable. So a procedure is nothing but is an assembly equivalent of a Java or C function. So like this you can able to create a procedure. I have taken here sample, a variable name proc. Sample is a variable name proc. So whatever the proc required program is being written here. And at last we have ret and sample end program. So this is the format for creating a procedure. Variable name proc, then whatever the instructions being required for the corresponding procedure, then ret and sample and p. This is how you need to create a procedure. Now procedure call and return already we have seen. Main proc, call from first instruction goes to the proc1 proc. For example, you have proc1, we are calling this, so the proc1 proc. So here it executes the first instruction, return back to the main program. Call and return instruction. What it does in a stack is the call instruction pushes the offset of next instruction onto the stack, copies the address of the called procedure into IP. Getting a point? So pushes your next instruction down and puts your address of the procedure address into IP. Then what ret instruction does? It pops to the stack into the IP. So before call, it is a main proc, call proc, the next instruction this one, first instruction. So how it will execute? So first stack pointer, it is pointing to 0100. So before any call, this is how the stack will be. It is an empty. So this is my program, which is main proc, call proc1 proc, return. Alright. So after call, what happens? See, after call, the call proc1, it goes to the address which is 0200, which sets the IP address stack pointer to the 0012. Getting a point here. So this is my top of the stack. So no, 00FE. So it address of the proc instruction is being here. So before ret, if it will be in this position, it will be in this position itself. After ret, it comes to the back to the position. So the back to the position. So the types of call instructions, we have two different, near call, far call. Within segment we can call near call, and inter segment we can call nothing but as we have four segments: code segment, data segment, extra segment, and stack segment. So if we are calling within the four segments, we have to use far call. If you are using any one of the segments within that corresponding segment, near call. So we can able to reduce the starting address of the procedure by adding a 16-bit signed displacement to the contents of the instruction pointer, used when the call procedure is in different segments. What is the difference between near and far? Near, nothing but within the same code segment. Far, within different code segments. Near, replace old IP with new IP. replace old pair, think but CS colon IP with new pair. If we have DS colon IP, value of IP is pushed onto the stack, value of pair CS colon IP is pushed onto the stack. So this near call we can call as intra-segment call, far call we can call as inter-segment call. So using push and pop, as we all know, push the register instruction decrements the stack pointer by 2 because 2 bytes of data can be emptied at one time. And pop will be copies the word onto the top of the stack to the specified 16-bit register or memory location. Nothing but increments the stack pointer by 2. Decrements the stack pointer by 2. Pop increments the stack pointer by 2. So there are major ways of passing parameters to and from a procedure. 3 different formats. The first one is in register, we can able to pass parameter. In dedicated memory locations accessed by name and with the stack. So these 3 are the different ways of passing the parameters to and from a procedure. Writing and debugging programs containing procedures. So carefully we have to work out the overall structure of the program and break it down into modules which can easily be written as procedures. Simulate each procedure with few instructions which simply pass test values to the mainline program. This is called as dummy or stubs. Check that number of push and pop operations are same. Use breakpoints before call, ret and start of the program or any key points in the program. So this is the different points which we need to keep in mind while writing and debugging the programs which contains procedures. So there are 2 types of procedures which are reentrant and recursive procedure. Reentrant, think but the procedure which can be interrupted used. The procedure which has already been used can be interrupted without losing or writing over anything. Is nothing but reentrant procedures. The procedures which can be interrupted, used and re-entered without losing or writing over anything. Recursive, it is the procedure which we call by itself. It is nothing but recursive. So already used procedure we can use as a re-entrant without losing or writing over anything. It is nothing but re-entrant procedure. Recursive is, it is the procedure which we call by itself. So this is how you can pass the parameters in 3 ways which are in register, in dedicated memory locations accessed by name and with the stack. Thank you.